Well, first of all, the acronym SIPs stands for Structural Insulated Panels. And this is a completely different way of building homes and workshops and such. Instead of a stick frame building with studs and plates and rafters and things, SIPs homes are built with panels. The acronym SIPs, as I said, stands for Structural Insulated Panels. And it's essentially a factory-made sandwich with foam in the middle and sheet goods on either side. So the foam is typically 3.5 to maybe 10.5 inches thick, and the sheet goods that are glued to that foam are usually oriented strand board, OSB. You build these with something like you'd build a house of cards, essentially. There are no studs, there's no wood framing or anything. You just simply stack the panels one next to the other to form walls, and you can actually use the same panels to form the roof without rafters, making a great, fully usable attic. These panels fit together with notches along the sides, and what's called a spline, which is a piece that fits into the notches and stabilizes one panel to the other. So it's a great system. I've built a number of buildings using SIPs. I've recommended it to others. They've built with it. They're really happy. Well, I guess the biggest reason is energy efficiency. There was a study done not so long ago in southern Ontario where two identical homes were built side by side by the same crew. One house was built using conventional methods, following building codes with all the regular amount of insulation in the walls and ceiling, and the other home, identical in floor plan, built by the same people, was built in exactly the same way except SIPs panels were used for the walls. Now, in this case, probes and analysis of the two different homes was ongoing after they were built, so we know exactly how much energy they consumed for different temperatures outside. And the bottom line is quite simple. The SIPs version of the house used half the energy of the other house. The really interesting thing, too, is that the SIPs home, technically speaking, had somewhat less R value in the walls than the other home built with stick frame and bad insulation. And this gets to the point that not all R values are the same. Some are much more effective functionally in the real world, because the R values you see published on packaging comes from lab analysis, not real world conditions. And in real world conditions, there can be an enormous difference in how the same R value performs. SIPs homes actually happen to be stronger than stick frame too, which is kind of strange because you'd think that a wood frame would make things stronger, but it's not so. A SIPs structure is roughly 3 times as strong as a comparable stick frame version. I've seen photos of homes in the Caribbean. They get hit regularly with hurricanes and things. There's one home in particular. It has been through 3 hurricanes, more or less unscathed, whereas all the other stick frame houses around it have been destroyed 3 separate times as these storms have landed. So there's lots of reason to use them. When I have bought these panels, I've bought them from a company called Thermapan. They're in Fort Erie, Ontario. They've been in business a long time. They do a great job. And there may be other manufacturers closer to you. I would be careful, though. There are manufacturers of panels, and that's who you'd like to deal with directly. There's also retailers of panels, and they're taking their cut, so it's going to be more expensive that way. So connecting with an actual manufacturer is the way to go. Maybe 2% more than a regular place. It's more expensive. It's more expensive than that when you look just at the wall structure, comparing stick frame to SIPs. But when you look at the overall cost of the house, you're looking at a couple of % of extra cost. Really very minimal for the extra strength, but more importantly, the energy efficiency. Building with SIPs is really simple. It's a lot easier and requires less skill to put up a SIPs wall than a stud frame wall. So any carpenter can do it. They're going to have to learn a few very simple different skills than they're used to. 2, additional tools are required, things that most carpenters probably have never used. One is some sort of a tool to cut the panels, which can get fairly thick sometimes. What I use is called a Prezi beam cutter. This is an attachment that goes onto a regular circular saw. It replaces the blade with a short little chainsaw style bar. So now you've got great cutting depth. So that's not expensive, and it can be added to pretty well any circular saw. So that's one unique tool that will be needed. Another unique tool is called a hot knife, and that's to reestablish the recessed edges on panels if you've cut that recessed edge off for whatever reason, because you have to cut a panel to a certain length or certain width. And that foam needs to be recessed back from the edges of the sheet goods so that the spline, the thing that connects one panel to the other, can fit into that space. Be watching this from anywhere in the world, and certainly there are going to be local suppliers in your area too, but it is definitely the way to go.